Hello, and welcome back to the Batcave. So last week I actually killed this transistor running a higher power and higher frequency test without filming it. Shame. This is an IGBT 400 amps, 1200 volts, 4000 amps continuous. But it's second hand and it's a copy because the new ones are really expensive. This is a new one. It's an Infineon. As you can see, it's still got the copper strip there, shorting the base out, which is I left that on there. This has been mounted using a silver-based compound, not the silicon stuff. This is a better conductivity rate, and more importantly, it remains sticky. It remains wet even after like 2 years. This has been there for at least a year, running in at many kilowatts. I've got actually 11 kilowatts available on this bench, so yeah, a bit risky place to sit. So yeah, I use the silver stuff because it remains sticky. The silicon dries out. If you want stuff that really dries out, it's apparently this stuff that was developed by NASA, called Stars 912. It was copied by somebody, and it's very good stuff. I use it. You can just glue a power transistor onto a heatsink or a piece of metal and heat it up to 60 degrees for a few minutes, and it'll glue itself in place. Okay, so going back, we're going to be running this at a lower frequency. This thermal glue, by the way, I used to glue the sensors on the coil to keep the temperature of the coil. And why does the coil get hot? Well, it gets hot because it needs to dump its energy into that plasma in that tube. And there's ways of doing this, which is to get the plasma hot enough and compress it enough. And what they're doing wrong with the tokamak is they're trying to spin it around in circles, using kinetic energy to heat it up. You don't need to do that. In fact, you don't need 100 million degrees. You can use 10 to 12 million degrees. You can fuse at a much lower temperature if you increase the pressure and the magnetic moment and the current through the plasma. And we'll get onto that in a minute, because obviously this coil, once it manages to dump its energy, it will then run cold, and it will be delivering 4,500 amps through this tiny tube of plasma, which will be superheated, and then you can fuse at a much lower temperature. Imagine then if we use a tube like this, which is actually 18 times the capacity. Or this one. Now, these are sealed tubes for a reason, because they'll be converted to helium. They'll give it energy. I'll record that energy. I'll hope to absorb that energy for the giant resistors I've got connected back there. But this is 30 times the energy of that one, and gram for gram deuterium it's about, I don't know, equivalent to 70 kilos of TNT, which will remove this lap. Imagine if I tried fusing this one. Well, we won't go there just yet, but there you go.